We have already seen that if a series is absolutely convergent, then rearranging the terms of the series is not going to affect its sum or its convergence behavior. Let's now see another algebraic operation that you could do to an infinite series. This operation is best illustrated by an example. Consider the series summation minus 1 power n equals 1 to infinity. Now it takes less than 30 seconds to show that this is divergent. This series is divergent. But by grouping terms together, not rearranging, note my choice of words, by grouping terms together, it is possible to show that this series is convergent. Of course, such a proof is faulty, but it's a good idea to first perform this proof and see where it goes wrong. Well, what you do is you look at, this is just minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. What I do is I group these terms together. I write this like this, put a plus sign here, group it like this, and you get the general idea. I get 0 plus 0 plus 0 plus dot dot dot. Okay? Clearly this regrouped series converges to 0. Converges to 0. Right? Why does this happen? This is weird. The original series is clearly not convergent, whereas this regrouped series is clearly convergent to 0. What is going wrong? Well, not to spoil your fun, I will just leave it to you to think about this, but let me just give you a hint. When you consider this regrouped series, you are not considering all partial sums of the original series. You are considering only some special partial sums. So this is analogous to there being a sequence that diverges, but having some subsequences that converge. That's exactly what is happening. So what I'm going to show now is that if the original series is convergent, then such groupings is still going to maintain convergence behavior. So theorem, let the series summation an be convergent to A, let's say. Okay, then consider a regrouping. Now how am I going to make regrouping precise? Well, that is, consider a subsequence of 1, 2, 3 dot dot dot. I'm just considering a subsequence of the natural numbers. Okay, call this subsequence, call it nk, and define a1 to be not a1 b1. Define b1 to be a1 plus a2 plus dot 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 an1. Then b2 is an1 plus 1 plus an1 plus 2 plus dot 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 plus an2, and you get the idea. b3 is just an2 plus 1 plus dot 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 an3. So essentially what I'm doing is I have this a1, a2, a3, a4 dot dot dot. A regrouping is just inserting parentheses at appropriate points, right, without changing the order. So I'm just inserting parentheses, doing this addition first, then this addition, then whatever addition comes next, so on and so forth. So that is neatly captured by just considering a subsequence of n and considering a new sequence whose first element is just a12 dot 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 an1. That is just this. Here the ordering really doesn't matter when you are taking these finite sums, but I'm just writing it in the same order. Okay, and then b2 is just this, b3 is just this, so on. I'm just grouping the terms together, and this definition perfectly captures what it means for a for this bk to be a regrouping. Then conclusion, summation bk is also equal to a. So the series bk, now I will not use bk, let me just write bn again. This series bn also converges to a. Now proof. The proof is rather easy. Let Sm be partial sums of an and ts, or let's say tl, l sounds better, tl be partial sums of bn. Then T1 is actually just Sn1, right? And T2 is just Sn2. Okay, think. Again, there's nothing really to explain. T1 is just Sn1, T2 is just Sn2 in general. This TL is just SNL, right? So hence this TL is actually a subsequence of SM, hence proved. Therefore we are done. That's it. Any subsequence of a convergent sequence must converge to the same point. So this was a really short module. What we have now shown is that you don't really require absolute convergence for grouping terms. Just convergence is enough to guarantee good behavior. This is a course on real analysis, and you have just watched the module on grouping terms of an infinite series.